Hello friends, myself R.D. Mahajan presenting my video on properties of Z transform. Second property, let us find Z transform of n multiplied by a raised to n, and to obtain its Z transform we apply this property. Therefore Z of n multiplied by a raised to n, as per this property it is minus 1 raised to n minus 1 raised to r is here 1 power of n. Z d by dz operated on f bar of z. F bar of z means z transform of this a raised to n. And then simplifying it, minus 1 raised to 1 is minus z d by z as it is, no change. And z transform of a raised to n, standard result, it is z upon z minus a. Condition for n greater than or equal to 0. And then minus z, differentiating this term with respect to z by quotient rule. Therefore z minus a, derivative of z is 1 minus z, differentiation of z minus a with respect to z is 1 and whole divided by z minus a whole square. Simplifying it, we get minus z into z minus z get cancelled. We have minus a divided by z minus a whole square. Minus minus it become plus. Therefore, it is az divided by z minus a whole square as z transform of n multiplied by a raised to n. As a required answer or required Z transform. Second example, find Z transform of L square minus 3n plus 2 condition n greater than or equal to 0. And to determine its Z transform, we obtain Z of individual term. Therefore, Z of n square minus 3n plus 2, nothing but Z transform of n square minus 3 constant outside, Z transform of n and plus 2 times Z transform of 1, and we call this equation 1. And then we try to determine Z of n square, Z of n and Z of 1 individually, and therefore step by step we perform it. First of all, I will obtain Z transform of n as Z transform of n multiplied by 1, as I had discussed in my previous video. And then as per this theorem property, it is minus 1 raised to r is here 1, z d by dz whole raised to r is 1, and z transform of 1. Then it is minus z d by dz z transform of 1, standard result, it is z upon z minus 1. Differentiating it with respect to z by quotient rule, we get minus z, denominator term z minus 1, derivative of z 1 minus z, differentiation of z minus 1 with respect to z is 1 and whole divided by z minus 1 whole square. It is minus z. Z minus z get cancelled. We have minus 1 remaining and divided by z minus 1 whole square. And therefore minus minus it become plus z upon z minus 1 whole square. We call this equation 2. Z transform of n square, where r is 2. As for this property, it is minus 1 raised to r is 2, z d by dz and whole raised to 2, and f bar of z means Z transform of 1. Then minus 1 raised to 2 is plus sign, positive sign. We split this as Z d by dz and again Z d by dz, and Z transform of 1 is Z upon Z minus 1, standard result. This is Z d by dz as it is, no change. This Z also as it is, no change. And in differentiating it with respect to Z by quotient rule, it is Z minus 1, derivative of Z is 1 minus Z. Differentiation of this Z minus 1 is 1 and whole divided by Z minus 1 whole square. It is Z d by dz, no change. Outer Z as it is. Simplifying it, Z get cancelled. Minus 1 upon Z minus 1 whole square. We take out minus sign outside, that is minus Z d by dz of Z upon Z minus 1 whole square. Again differentiating it with respect to Z, minus Z, no change. Z minus 1 whole square, derivative of Z with respect to Z is 1 minus Z. Differentiation of this term is 2 times Z minus 1 and whole divided by Z minus 1 square of it. Therefore it becomes raised to 4. From these two terms we can take Z minus 1 common. Remaining terms are Z minus 1 and minus 2Z whole divided by Z minus 1 raised to 4. Simplifying it, Z minus 1 cancel with 1 Z minus 1, therefore minus Z multiplied by Z minus 2Z, we get minus Z and minus 1 whole divided by Z minus 1 cube. Taking minus sign common, that minus and this outer minus, it becomes plus Z plus 1 whole divided by Z minus 1 cube. We call this equation 3. This is Z transform of n square. Substituting the values in equation 1, we get Z transform of n square minus 3n plus 2 as Z transform of n square is Z into Z plus 1 divided by Z minus 1 whole cube minus 3 times Z transform of n is Z upon Z minus 1 whole square plus 2 times Z transform of 1 is Z upon Z minus 1. Therefore, this is the required Z transform of that function n square minus 3n plus 2. In my next video, I will discuss the third property. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, you have to press the bell icon. Thank you. Thanks for watching.